Hi, thank you for your interest in this talk. My name is Irene Finestrat, and today I will be talking about assessing individual neurocognitive differences in native language morphosyntactic processing as revealed by event-related potentials or ERP research. Based on almost 20 years of ERP evidence, the field generally expects that when native speakers process grammatical violations, a biphasic land P600 effect is elicited, which is taken to reflect syntactic processing and reanalysis. However, recent evidence shows that a monolithic response is not always the case, revealing individual variability in grammatical processing among native speakers. Quantitative difference record the magnitude of the effect elicited, whereas qualitative evidence shows that this traditional biphasic pattern is not characteristic of most participant responses. Instead, most participants show either an M400 or P600 dominant profile. So what evidence do we have for this M400 P600 dominance profile? Regarding effect magnitudes, we find differences in the relative size of the ERP effect elicited during grammatical processing. For example, in this graph, each participant is a dot. Participants' P600 magnitudes are represented on the x-axis, and on the y-axis, we have participants' M400 magnitudes. This dashed line that we have over here represents equal M400 and P600 effect magnitudes. Now, every participant who is above or to the left of that dashed line show primarily a negative response. And here is a representative waveform for somebody who is M400 dominant. On the other hand, people to the left of the dashed line showed primarily a positive response. And here is again a representative waveform for somebody who is positive or P600 dominant. And as you can see, there is a negative correlation between the two effect magnitudes. That is, the bigger the positivity of a participant, the smaller their negativity, and vice versa. Or said in other words, the more P600, the less N400. This is what has been called the N400 P600 continuum, along which our speakers vary when processing grammar. Now, another way to account for individual differences in language processing is to look at individuals' response dominance index, or RDI, which is a measure of participants' relative response dominance. An RDI value of 0 or near 0 would correspond to equal size M400 and P600 effects. A more positive value would reflect bigger P600 or dominant P600 profiles, whereas a more negative value would mean an M400 dominant speaker. And as you can see in these violin plots, there's a lot of variability in speaker response dominance, or RDIs. So what does this mean that speakers show either an M400 or a P600 dominant profile? Well, previous research has taken this individual level variation to reflect differences in processing strategies that are used to parse morphosyntactic violations. In particular, individuals who show primarily an M400 response are hypothesized to rely on memory-based, also referred to as good enough heuristics, while participants who elicit mainly an P600 effect are hypothesized to rely on combinatorial processes to determine correct from violation sentences. So with this evidence of significant variability, now the next step is to understand where this variability comes from. So research has shown that quantitative differences in effect magnitudes are influenced, for example, by literacy and proficiency in the language, with more literate participants showing bigger responses. Regarding qualitative difference, results are somewhat inconclusive, and we have only found familial sinistrality and sometimes working memory to play a role in determining who is an M400 or P600 dominant profile. So we find it difficult to explain individual differences in response dominance. In addition, the validity of this evidence has been called into question, arguing that this variability could be the result of measurement error. However, addressing validity claims, Tanner recently showed that individual differences were stable across conditions using the RDI, the measure that I was referring to before, as a measure of individual variability. As you can see in this graph, he found a significant correlation between RDIs in subject-verb number agreement conditions realized through a lexical verb or through an auxiliary verb. So in this project, we aim to advance the field's efforts to characterize neurocognitive individual differences in native language grammatical processing with two main goals. First, to replicate evidence of individual differences in grammatical processing along that N400 to P600 continuum that I was explaining before. And here we expect to find this negative relationship between N400 and P600 effect magnitudes. Second, we aim to examine consistency of ERP dominance, that consistency of that variability that we find across different morphosyntactic and syntactic structures. Based on Tanner 2019, we expect to find a positive relationship between RDIs across the different conditions, or at least among the agreement conditions. So in order to address these questions, we collected data from 15 native speakers of English who were around 21 years of age. Some of them were bilinguals or were learning a second language. In order to assess processing, we recorded EEG as participants completed a grammaticality judgment task in which they read 244 sentences, one word at a time, as in this example that I'm showing here. My brother buys roses, good or bad. We had 3 experimental conditions, 1 syntactic condition, the phrase structure, and 2 morphosyntactic conditions, subject verb number agreement and determiner noun number agreement. So we followed the standard experimental procedures in our lab to record and analyze EEG data. And if you have any questions about these specifications, I would be happy to address them in the Q&A. So now, moving on to analysis, we followed the procedures from Tanner 2019. The first step was to characterize individual differences in first language grammatical processing in order to address our first research question. So to do so, we calculated N400 and P600 effective magnitudes over central parietal region of interest, using the 3 to 500 millisecond and 600 to 900 millisecond time windows to tap into N400 and P600 effects respectively. And then we examined the correlation between the two effects in order to determine if participants exhibited either an N400 or a P600 effect. In this case, we would see that negative correlation that I was showing before, or on the other hand, if we find a biphasic pattern, and in this case, we would not see that correlation. Second, in order to determine the stability of the effects and address research question 2, for each participant, we calculated their RDI using this formula from Tanner, which consists in fitting each participant's least square distance from the equal N400 and P600 magnitude line that I was showing before. And then what we did is run correlation analysis with RDIs for or 3 different experimental conditions. So now we are ready to look at some of the results. I want to start by briefly reviewing group average results. On the left, we have waveforms for one representative electrode, CC, and the red line represents processing of the violation, whereas the black one represents processing of the correct sentence. And note that here, positive is plotted down and negative is plotted up. On the right side, we have our brain waves. Red is positive voltage and blue is negative voltage. The first column is the overall response within 3 to 500 millisecond time window, where we would expect an N400. And the second column is the 600 to 900 millisecond time window, where we would expect a P600 effect. As you can see in these waveforms, we saw a significant N400 for the phrase structure condition and also significant P600s for or 3 conditions. Now we are going to address the first research question and look at subject level variability of ERP responses. The scatter plot that I'm showing here should probably look familiar to you already. Here I'm showing the distribution of individuals' brain responses. And again, as I mentioned before, on the y-axis, we have participants in 400 magnitudes. On the x-axis or p600 magnitudes, and the dashed line would represent equal in 400 and p600 magnitudes. So as you can see, most participants exhibited one effect or the other, but not both responses. Indeed, correlation analysis, as we see here, revealed significant negative correlations between N400 and P600 effect magnitudes for the three experimental conditions. That is, the bigger the N400, the smaller the P600, and vice versa. So going back to our research question, our results replicated previous evidence of significant variability in first language grammatical processing. That is, native speakers do not always use the same mechanisms to process grammar in their first language. Now we can examine results that address the second research question, that is, looking at the stability of individual differences across different grammatical conditions. And first, we are going to look at the effect magnitudes, the N400 and P600 magnitudes. Results showed significant associations only in the P600 time window. And in particular, we see a significant positive relationship between P600 effect magnitudes for or two agreement conditions, the noun phrase and the subject verb agreement conditions, as well as between the noun phrase condition and the phrase structure, but nothing for the P600 time window. Now we are going to examine the correlations across conditions regarding RDIs. And results show a significant association between RDIs in the two morphosyntactic conditions, the subject verb and the noun phrase conditions, as you can see highlighted in the table, as well as in this scatter plot, but not with the phrase structure condition. So going back to the research questions, we see that those individual differences seem to be stable across morphosyntactic conditions. However, this pattern does not seem to extend to processing of syntax. In conclusion, our results replicate individual variability along the N400 P600 continuum in first language grammatical processing, revealing once again that grand average group responses do not always reflect the responses of most speakers. This evidence also indicates the lack of a unified native speaker norm to compare second language processing. And so we question the concept of native likeness in second language research. In addition, our results suggest that the stability of the RDI might depend on the nature of the linguistic form. While response dominance may reflect a stable trait in how morphosyntactic violations are processed, this finding does not seem to generalize to syntactic processing. We believe that this is an important avenue of research to further understand grammatical processing, but we need more evidence, potentially with different analyses that address limitations regarding time window based analysis, and so that we can better understand variability among first language speakers and also the factors that drive it. Finally, I wanted to thank everyone who made this project happen. I'll be happy to respond to any questions, so feel free to leave me a comment. I'll be happy to respond. Thank you so much.